point, they call it as D. Here it is given 6 centimeter, and this side it is 8 centimeter, and this is an ABC. So inside a triangle, we have a circle. Inside the triangle, we have a circle. We have to find the sides AB and AC. And they have given the side BC. Okay, they've given the side BC. CD is 6, BD is 8. Okay, so find the sides AB and AC. Find AB and AC. This is a given thing. So what we will try to do is, we will try to find the area of the bigger triangle ABC, and also try to find the area of the small 3 triangles here. That is AOB, AOC and BOC. These 3 triangles, we'll try to find the area. And we'll also try to find the area of a bigger triangle ABC. If I add all the small triangles, then it will be equal to area of the bigger triangle. Okay. So now from that, we will try to find the sides AC and AB. And we know that from an external point, if you draw 2 tangents, they are equal. Correct? So I'll mark this point as E and this point as F. So CE is also 6 and BF is also 8. BF is 8. Now I don't know AE and CF, so I'll take it as X. Now we will first try to find the area. And what AOC, in the triangle AOC, this is a base and this is a perpendicular, correct? Half into base into height. So always how you will take the area of the triangle, half into base into height. This is, if I'm considering this is a base. So from the other point, if I draw the altitude, that is the height. Okay. So if I consider ABC, for example, one triangle here. So BC is the base, means the altitude drawn from A to BC will be the height. Okay, so that way we will try to take that. First, area of triangle AOC. And what is the radius of the circle he has given? 4 centimeter has given. Okay. So area of triangle AOC is equal to half into base into height. So that is half into base is 6 plus x is the base and height is 4. Okay. Then area of triangle AOB. Okay. AOB. Okay, in this triangle. So what you will get? Half into base, I will take it as AB. And height will be, this point is O, OF is the height. Okay, so half into 8 plus x. This into 4 is the altitude. Similarly, area of triangle COB. So half into base is CD, that is 6 plus 8. This into 4 will be the height. Okay. So half into, this will be 4 into 6 plus 8, 14 you will get here. So this is the area what we can add everything, that is also equal to area of triangle ABC. Correct? Na? Add all the 3, how much you will get? 1, 2 and 3. Add everything now. Here I can cancel 2. Area of triangle ABC is equal to area of triangle AOC plus area of triangle AOB plus area of triangle CO. Okay. So this is equal to, I can see here 2 into 6 plus x plus 2 into 8 plus x plus 14 into ABC. How do you calculate using the Heron's formula? S into S minus A into S minus B into S minus C, where A, B, C are the sides of the triangle. What are the sides of this triangle? One side it is 14, another side it is 6 plus x, another side it is 8 plus x. Okay. What is S? It is half of the perimeter, that is 6 plus x plus 8 plus x plus 14 by 2. So S is equal to x plus x is 2x plus, how much you will get? 14 plus 14, that is 2 into 14 by 2. Or yes, 2 if I take common, and I can cancel 2's here. So S is equal to x plus 14 you will get. Okay. So area of triangle ABC is equal to now root of S is x plus 14 or 14 plus x into, what is x? S is 14 plus x minus A. Here it is, if I take A as 14, so here it is 14 into, now 14 plus x minus of 6 plus x. Next, you have 14 plus x minus of 8 plus x. Each side we have to. So what you will get? This is 14 plus x into x. This into, you will get 14 minus 6. X and x will cancel. 14 minus 6. So it is 8. Here x and minus x will cancel. 14 minus 8. So you will get 6. Okay. So this is the one. And now equate it with the, this is equation 2. Earlier what we got was the equation 1. So try to equate them because they are both are equal to area of the triangle ABC. Okay. Then we try to calculate. Just see that. So what we got earlier one. What we got? Where is the earlier one? Here. 56 plus 4x. Correct. Why you have scratched?
Ma'am, I didn't understand this one.
Correct only, no? So that is also equal to 2 into 6 plus x plus 2 into 8 plus x plus 14 into 2. If you try to simplify this, what you will get? 12 plus 2x plus 16 plus 2x plus 20. 4x plus 56, I think, na? You will get 56, correct. Take 4 common here. What else is remaining? X plus 14. X plus 14 you will get. Yeah. So this equation is equal to this. These two are equal now. This was 1 and so what we have got, 4 into x plus 14 is equal to root of 14 plus x into 8 into 6. So squaring on both sides, what you will get? Squaring on both sides. 4 square is 16. 16 into x square plus 14. X plus 14 whole square. Squaring on both sides, it is equal to 14 plus x into 8 into 6. It is 1 x plus 14 and x plus 14 I can cancel now. So now simplify. And 16x plus 16 into 14. 56x. Shift this to the other side. 56x minus 16x is equal to 16 into 14. You will get.
Ma'am, 8 6 are 48, not 56.
Okay. Here now. 48 minus 16 you will get. We'll say. How much you will get? I think x is equal to 7, I think. That's how much you will get simplify? I think x is equal to 7. Simplify and tell me the answer how much you will get. 7 you will get. No. Understood, no? So what we are trying to do is, one, we are using the Heron's formula, that is root of s into s minus a into s minus b into s minus c. Another one, half into base into height. 3 triangles, smaller triangles we will get all together equal to bigger triangle. Trying to equate both, and we are trying to find the x values. For the smaller triangle, we are using like from the one external point, two lengths, two tangents are equal. So one we know, we can find the other. Okay. The unknown one we will take it as x and we will try to find that. So PQRS. Okay. So prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. So the quadrilateral will make the angles, opposite angles here with the circle like this. So this is AOB and this is COD. We have to prove that AOB plus COD is equal to 180 degree. We have to prove that these two angles sum is equal to 180 degree. Okay. Given quadrilateral circumscribing a circle. Okay, circumscribing a circle. So quadrilateral, we name it as ABCD, and Q is a point where the circle and the quadrilateral is the point of contact between the circle and the quadrilateral. Okay, so from point A, AQ and AP are the tangents. Some point D, DP and DS are the tangents. Some from the point C, CS and CR are the tangents, and from point B, BQ and BR are the tangents. They are equal tangents, correct? So from the diagram, what we observe, AQ, AP are the equal tangents, DP and DS are equal tangents, CR and CS are equal tangents, BQ and BR are equal tangents. Okay. Now we have to prove these two angles equal, and around a point we know that they are equal to 360 degree. Around a point, whatever the angles we have, that is equal to 360 degree. Now we have to prove that the sum of these two opposite angles is equal to 180 degree. So for that, We'll first join the points here. We will name them. Each one is angle 1, angle 2, 3, 4, 5, 6, 7, and 8. Okay. So all the angles 1 to 8 we will name them. We have joined OQ, OR, OS, OP. Okay. And we got 8 angles. Sum of all these should be equal to 360 degree, because around a point it is equal to 360 degree. So first to prove that AOB plus COD is equal to 1. Proof. Angle 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. All angles together it is 360 degree. What is the reason? Sum of all angles around A point is 360 degrees. Sum of all the angles around a point it is 360 degrees. Okay. Now if you observe in these two triangles AOQ and AOP, AP is equal to AQ, OQ is equal to OP because they are the same radius, and AO is the common side. So these two triangles are congruent. See if I draw once. AQP, if I consider AQ is equal to AP, you will get AO is equal to AO, and OQ is equal to OP. Because all sides are equal, you will get. So these two triangles will be congruent. Similarly, these two triangles are congruent. Here, these two triangles congruent and these two triangles congruent, you will get. Once they are congruent, by CPCP rule, I can say angles are equal. So 1 and 8 equal, 2 and 3 equal, 4 and 5 equal, 7 and 6 equal. Okay. So instead of 8, I can write 1 only. Instead of in this 2 and 3, instead of 3, I can write 2. Correct. And here 3, these two angles, then again 7 and 6 are equal. Correct. So in this, instead of 7, I can write 6 like that. 2 times I can write and I will be able to find the results. Okay. So write that. In triangle AOQ and AOP, what you will get AP is equal to AQ. Because same reason, tangents from external point are equal. Okay. Then OA is equal to OA, OQ is equal to OP because the radii of the same circle. Therefore, triangle AOQ is congruent to triangle AOP by SSS congruency rule. By SSS congruency rule. Okay. Therefore, angle 1 is equal to angle 8 by CPCP rule. Similarly, this I've written P, no? PQRS, right? Name it. P is the P should be there. Here. Huh? Yeah. Yeah. Huh. Similarly, BOQ. Triangle BOQ is congruent to triangle BOR. Therefore, angle 2 is equal to angle 3. Similarly, I can say 4 and 5 angles are equal. 6 and 7 are equal. Okay. So I can write is we have 1 plus 2 plus 3 plus 4, 5, 6, 7 and 8. Together it is 360 degree. Now angle 1 and 8 are equal. So I can write 2 times angle 1 plus. Then 2 and 3 are equal. So I can write 2 times angle 2 plus. Now 4 and 5 are equal. So I can write 2 times angle 5 plus 6 and 7 angle equal to times angle 6 is equal to 360, or 1 plus 2 plus 5 plus 6 is equal to 180 degree. Now what is 1 plus 2? AOB. Therefore angle AOB plus 5 plus 6 is COD is equal to 1. So their sum is equal to supplement. PQ is the chord of a circle which is 8 centimeter and radius it is 5 centimeter. Okay, in the radius it is given 5 centimeters. Now the tangents at P and Q intersect at point T. So tangents at P and Q intersect at point T. Find the length of TP. You have to find the length of the TP. This is a given question. So the radius is 5 centimeter. Okay, radius is the 5 centimeter. This point we call it as R. PR is how much now? 4. And QR is also 4 centimeter. Now you have to find PT length, which is also equal to PQ length. Okay. So what is given here? OP is equal to 5 centimeter. PQ is equal to 8 centimeter. So to prove that, want to prove fine. Okay. So you have to find length TP. Okay. So proof. First thing, PR, since it is a perpendicular drawn to the chord from the center, OR is a perpendicular drawn to the chord PQ. So PR is equal to RQ, that is equal to 4 centimeter. PR is equal to RQ, that is 4 centimeter, that is perpendicular divides the chord into 2 equal parts. Divides the chord into 2 equal parts. Okay. Now we have to find the length of the tangent. To find the length of the tangent, there are 2 methods what they've given. One, using the similarity criterion. 2 triangles will prove similar. From that, we will take the ratios and we will find. Other one is by the Pythagoras theorem. Other one is by Pythagoras theorem. We can prove that. Okay. Pythagoras theorem, actually, I find it easier to do. Just write down once. Okay, Pythagoras theorem. By Pythagoras theorem. By Pythagoras theorem. So TP I will keep it as X. TP as X. Now by Pythagoras theorem, what I can write? TP is X. And what is this OR length equal to? See, if you PRO is also a triangle. This is 90 degree. Opposite to this is the hypotenuse. So what will be this? By triplet, we'll know it is 3. So first, by Pythagoras theorem, PRO, triangle PRO, OP square will be equal to OR square plus PR square. So OR square is equal to OP square is 5 square minus the 4 square. So 16 minus 25 minus 16. So OR is equal to 3 centimeter. So we will get this much. Write down this. So this is 5. This length will be 3 O and this is R. OR is 3, OP is 5 and PR is 4. Okay, we have to find PT. Now we can have the two Pythagoras here. One is this small triangle is there. Another one now PTR is also an right angle triangle because this is 90 degree. Okay, in triangle PTR. R is 90 degrees, so PT is the hypotenuse. PT square will be equal to TR square plus PR square. So we have taken PT as X and PR also we don't know, that we will take it as Y. So PT square is what? X square is equal to Y square plus 4 square. So this is one equation we can take. Okay, so this is the one equation we have to take. That is x square is equal to y square plus 16. So this is equation 1. Next, another bigger triangle we'll take PTO. In triangle PTO. PTO. Angle P is 90 degree here. If you observe, this is 90 degree, right? PTO. Angle P is 90 degree. So OT is the hypotenuse. So in triangle PTO, OT square will be equal to PT square plus OP square. Okay. So OT is what? Y plus 3. Now that is equal to PT. PT is x square plus OP square is 5 square. Okay. So I can write x square is equal to y plus 3 whole square minus 25. This is second equation. Compare 1 and 2. Both are equal to x square. So I can find y. Y square plus 16 is equal to y plus 3 whole square minus 25. Now try to simplify. What is a y value? We have to calculate. Y square is equal to plus 16, 25 I'll take to this side, plus 25 is equal to a plus b whole square is what? Y square plus 3 square is 9 plus 2ab, 2 into 3 into y. Y square and y square I can cancel here. So 25 plus 16. So 41. 9 you can shift here, minus 9 is equal to 6y. Y you should find. So what is the y value you will get? Y is equal to 2 by 6. So y is equal to 32 by 6, that is y is equal to 16 by 3. Now find x value. How to find the x value? X square is equal to y square plus 16. Find the x value. Correct. 20 by 3. X is equal to 20 by 3. Good. X is equal to 20 by 3. Okay. So this is how we can find Pythagoras theorem. The other way is you can use the similarity criterion and also you can prove. That is, we can prove that these two triangles are similar. Okay. A criterion and we can say. One is 90 and 90. You will get. Angle. One more angle you have to find. Here we will end today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.